Hot chocolate, Azure, Cosmos, Nappa. Entity framework, power tools. Technology suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Likeness.
Shay Rojansky.
Grace Lampson.
Martha Vickers.
.NET data. T-minus 1 minute. Thirty seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Stand-Up.
Welcome. We're here with another .NET Data Community Stand-Up. And some of the comments already. Yes, you are free to dance. We fully encourage that. You might want to sit down for some content today because we've got a great session on pagination. Where you come from or how you say it. We have Mohammed Rahhal, I hope I said that right, who is author of a library that does keyset pagination in EF4, and he's going to show us some of that stuff and talk about that. And then we also have Shay, who goes through some general pagination stuff, and Jeremy in the background pressing buttons, answering questions, and being Jeremy as usual. But before we do that, let's do State of the Unicorn. So May the 4th be with you. As you all know, anyway, enough said about that. But our unicorns have lightsabers or some form of laser sword, which is not protected by copyright or anything. So here we go. What's been going on? Well, there's a couple of new learning videos in the last 2 weeks. Firstly, we have this introduction to EF Core for beginners, and this is actually a whole series of videos by Cam Soper, who is on our team here at Microsoft doing learning videos, and these are really good intro, get it started type stuff. So there's that. And then there's also this week been a Let's Learn .NET data event. So Let's Learn .NET has various events where they teach you about all stuff in .NET. And so Jeremy, Shay, and I joined the Let's Learn team with Jamie and John and Cam, there last week, I think. And we built a web API with EF Core from scratch in VS Code. So if you want to hear me talking through a lot of kind of basic but not so basic stuff in that, then check that out. We covered migrations. I don't know if we maybe didn't get to database first. I'm not sure. I talked about using DI and showed that integrates with ASP.NET. We did a lot of model configuration stuff, and we answered a lot of questions. So that is also available on YouTube, and the links for these are in the show links if you want to see them. So yep, that's available as well. So some good videos. Okay, so in the EF7 daily builds, I've been working on interceptors, lifecycle hooks. I'm starting to look at materialization, which is the one everybody wants, but just to kind of, get back into the flow of it, I've done the connection created and disposed, and we have a command initialized interception. Shay has done further performance improvements for safe changes. I think we're pretty much done with those for now, although some more may come later. So EF7 continuing, and then TPC is going well, but we still need to get Smith to do some query work on there before it's kind of fully usable. Unfortunately, we had some resourcing constraints and for various reasons, and so we've had to make a few cuts to the original plan. We're not evolving system link expression at the moment. This isn't really our team, but we were trying to work with the Roslyn team on this, and the .NET directors decided this wasn't high enough priority to do at the moment, so that's been cut for now. But if you need this, send us feedback, let us know, because it will help us get it in there in the future. Likewise, we looked at the new link operators that are there, and for now, we're not going to translate them. While they can be useful, some of the translations are a bit complex, and just in terms of resourcing, we thought it would be better to focus our time on some of the other things. It's always painful when you make these cuts. And then Shay had been looking into open telemetry across various ADO.NET providers, but I don't think that's really going to make it for 7. I still plan to do it in the future. And Bryce has had to go work on some other stuff recently, and so non-EF stuff, and so we've cut some of the experience improvements to migration that we thought we were going to do. And then finally, probably if you're listening to this, you're already aware that legacy EF6, this is not EF Core 6, but the old stack, hasn't really been worked on for a while now. We're focusing on the team on EF Core, and so we've kind of updated the GitHub page just to make it clear that we're going for stability there. We want to keep that stable, so we're not really making any changes by design to that. It's still supported. It'll still get security fixes. You can still use it and contact Microsoft support, and you'll get the normal thing there. But we're not adding features, and we're generally not fixing bugs unless they're like really serious. So that's where we are on State of the Unicorn, and I think I will now pass over to Shay to start talking about pagination.
Awesome. So hi, everybody. We're going to be talking about something which I think a lot of people, have to deal with all the time, especially in UI applications, pagination, which is when you have, a whole lot of things that you want to show, some big list. And obviously, you can't show the big list in one single time because that would be too much. So you have a pagination kind of thing in your UI. Now, I'm gonna talk for a while about the basic things and some basic messages and show some perf. But the idea is also to set the stage so that Mohammed can show some very impressive libraries built on top of EF Core, which kind of guide you and help you do things the right way with a great API as well. So first, Jeremy or Arthur, if we can see my screen, I just want to show. So in our URL list this time are some very important links. So we don't always put that many links there. First of all, a lot of the high-level stuff that we're gonna talk about is covered by this blog post, which I highly recommend. So anybody doing any form of pagination, I really recommend you go read this. This is a sort of a manifesto. It's very easy to read. It's not very technical. It just, the guy is obviously very opinionated. He does not like offset, as you can maybe see. Do not use offset for pagination. It's kind of like, radioactive waste. I hope we will be able to explain. The idea here is to explain to you what this is all about. But I really highly recommend reading this. It's basically the same kind of message that we have. Now, we also have a page in our own EF Core docs, which is specifically EF Core again, that takes up some of these themes as well. So it kind of repeats some of it, but also goes into more detail in EF Core. This is in our query data. There's a specific page for pagination, which again takes talks about a lot of the stuff that we're going to be talking in this thing. And for those who really want to dive in a bit deeper, there's a very, very good presentation that I really highly recommend here. It's more Postgres kind of centric, but the general message is completely universal. So again, same themes. It talks about why offset-based pagination is a bad idea. You'll understand what that means in a second. It goes into a lot of perf analysis on why that is. So I really highly, highly recommend this for the more, let's say, deep dive side of things. Okay, so at this point, as usual, we have our metric of time to code, how quickly to get to the demo, to actual code on the screen. So I'm going to share my, yes, let's see, the window with the pagination stuff. I'm going to say pagination. That seems better to me. If somebody can share my screen now. Yes, that's exactly what I wanted to show. Okay, so we're going to be seeing a little bit of code. I did this demo on Postgres, but the concepts are universal. So you're going to see the same thing on SQL Server or various other databases. So what I've done here is I've prepared a very basic table in the database called blogs. It has a generated ID, it has a name, and it has a last updated date field. That's kind of important. Here is some sort of magical incantation in Postgres that basically seeds us with 1 billion rows, because we're about to talk about performance a little bit. So it's always important to have enough rows in the database to actually show it. I'm just going to show what this looks like by running this, this thing. And as you can see, very simple kind of table. Nothing to write home about, nothing very exciting. Let's go and see our actual program here. So now we're in EF. No, you don't need to be scared about any Postgres raw SQL here anymore. We're back in the nice, comfortable world of EF. What we have is a blogging context. Everything is very, very trivial here. We have a DB set of blogs, and we're mapping the blogs this way. I see I even forgot to put the name in because it's not very important. We have the ID and the last updated. And then what you have here, and this is where we actually start digging into it, is a very, very standard kind of query, which we use in pagination context. So what we have is we look at the blogs, we order them by something. In this case, we're going to order them by the ID. That's how we want to display our blogs to our users, by the ID. We'll talk about that later. And then we have skip and take. So this is the universal kind of accepted way of doing pagination. That's exactly what we're going to argue against. So this whole no offset thing, which you saw before, is about the skip here. So it turns out skip is actually evil in various ways. One of the presentations that that we linked to says skip is like sleep. It basically makes your program pause for more the bigger it is. And you'll soon understand exactly what that means. I have to admit, by the way, that a year ago, I wasn't aware of any of this. I would blissfully write code like this, like with skip and take, and I thought that was awesome. In fact, it is not awesome at all. We will soon see. So what you see here, the take here is our page size. So we want to show on our UI, 10 blogs on each page. And the skip means that we're basically showing the third page here. Now, I debated, I almost wrote like a full ASP.NET application with a UI and everything. But because we want to dig in, also to performance and show the SQL, what I did was more of a console program that allows us to really focus on that query and show what it is. So I'm going to run this just so that, we get the SQL in everybody's minds like that. So it's running, and what we get is this. So this is PostgreSQL, but SQL Server is going to do something very similar. We have our order by clause, and then we have a limit and an offset. So, and the limit is the take clause. So this is our page size, which is 10. And the offset is how many rows we want to skip to get to the page that we're actually wanting. So the third page, and so on. Okay, that is awesome, but there is a problem here, okay? It turns out that even if we have, we're ordering by the ID, and everybody knows there's an index on, the primary key ID of databases, no problem there. But it turns out that when you use the skip operator or offset, as it's called in standard SQL, indexes can be used but they are not optimized to support this specific thing. What I mean is that when you skip 20 rows, the database still has to go and basically look through 20 rows, skip those 20 rows in order to reach the row 21, which is what we want to have. The horrible thing about this, maybe to drive the point home, is that the more rows we skip, the more work we're asking the database to do. That means that as your users are clicking next page, next page, next page, next page, your pagination UI becomes slower and slower and slower, which is a pretty bad thing when you think about it, right? I mean, sorry, you wanted to say something, Mohammed, maybe?
Yes, I want to say that this
Please
is
interrupt.
this is especially the case when you have a random access paging toolbar in your pages. So this is especially the case then, because the user would be able to fast forward to the millionth page. So this is a real performance problem when it comes to offset-based pagination. Yeah,
Exactly, and that's why you saw that blog post I started with the no offset. In fact, that's really a big problem. It turns out this is a huge anti-pattern, and the amazing thing about it is that nobody really knows about it. At least I didn't know about it. I know in our team this didn't used to be a very well-known fact. It's this kind of little known fact in database programming. At least it seems that way to me a little bit. We see a lot of queries which have skip operators. Although once again, this is something that usually is not a good idea. Okay.
I feel like there's a very logical explanation why this is not very known.
I'm interested.
Yes, it's well, usually you look at the first page, the second page. There aren't many use cases where you would profile performance for the millionth page or something like that. So the performance hit is only present in certain cases, and it keeps getting worse and worse the more you skip pages. So this is why I feel it's not very known as a problem.
That's a good point. I tend to agree, and it also shows the importance when you're doing performance analysis. You can do it badly, or you can think about a very comprehensive thing and do it well. And it's hard to do well.
I think it's also that it's so easy, right? I mean, you just so this is one of those cases where I'm a big fan of LINQ, but LINQ makes doing this so easy with skip and take that you don't even think about it, because you're not even writing the SQL and thinking about what the SQL doing. Really, you're just doing it. I mean, even though it's kind of obvious when you say it, it's just so easy and so common to write skip take, and you can compose it over LINQ very easily and all those kind of things. So it's just A quick question we had here that I throw in there: is this applicable to NoSQL databases? If we're doing Cosmos, do we have the same issue here, for example?
We generally do. So it's hard to generalize about NoSQL databases. Relational databases are very similar in general in their concepts. They're alike. So Postgres and SQL Server obviously have a lot of differences, but they tend to be kind of similar in their core. Whereas NoSQL databases tend to be more diverse. So I can't generalize over NoSQL databases. I do know that in Cosmos you basically have the same thing. So you always have this problem when you ask the database, give me skip 1,000 rows. What does that mean? How is a database actually supposed to do that, right? Even a NoSQL database. In general, they're just going to go through as if you ask for, the first 1,000 rows. It's just not going to return them, but it's still going to do the processing necessary to go through them. That's basically the problem here. So I would say as a default suspicion, be suspicious and assume that, yes, this is relevant also for your NoSQL database. But of course, details may actually vary. Okay.
And I think it's one of these things that we hammer on all the time, but I just want to bring it up here so we can hammer on it again. You need an order by, even if you're doing primary key. Relational databases don't have default orderings. If you think I'm wrong, go Google it, because I'm not.
Yes.
Yeah. And I'll just add on the NoSQL, there's the added strategy, if you will, of understanding how partition keys work, and if you're paging across partitions or within a partition. So there's a different approach with document databases with continuation tokens, and there's a streamlined way to page things, and then there's a more mechanical way that has similar issues.
So it could, in fact, be a lot worse, even if you've got a big Cosmos database and you try to skip over 1,000 rows than it is
Oh,
on the
yes.
relational. Could
Yes.
be even worse. Yeah.
Absolutely, absolutely. Cosmos, by the way, it's an interesting thing. I don't want to get too much into it because we have a lot to cover. Cosmos does have the continuation token approach. It works very well as long as you're moving forward. But the moment you want to move back, then you have a problem because continuation
Yes.
tokens continue forward, right? Anyway, that's again, I'm going to resist the urge. There's lots of interesting tidbits here, but I'm not going to go into it. There's actually another problem with this style of pagination, which has absolutely nothing to do with perf. So when you're telling your database, I want, rows 20 to 30, that works, okay, there's the performance problem, but there's also a problem in the face of concurrent updates. So as the user is doing pagination, they're clicking next page. What happens if somebody is modifying the database at the exact same point? So a concurrent kind of situation. If somebody, if for example, I'm on page, I'm seeing rows 20 to 30, and before I click next page, somebody has deleted a row, like let's say the first row, then the whole result set kind of moves back, right? If you think about it. And the next time I click next row, I will have skipped over a row. I will have effectively lost a row in my pagination. Or if somebody adds a row in the very beginning, then I'm going to get a duplicate row. So the last row that I saw in the last page is going to appear again as the first row in the next page. I hope this is clear to everybody, this kind of concept that I'm always looking at a window of the result set as it's ordered, right? And that window, the actual data underlying this window, this kind of view that I have is maybe constantly moving depending on what's actually happening and concurrency.
It's kind of an absolute reference into the data, so that makes sense.
Yeah, that's correct. Exactly. And it turns out that's not an awesome way to do pagination. So we don't want users to suddenly see the same row twice or to suddenly skip a row, which is probably even worse, right? They've literally missed a row because somebody removed some unrelated row while they were paginating. That's a problem. That's something that usually is an unacceptable thing in a pagination interface. So we've covered two problems here. One is the perf thing, and the other one is the the concurrency kind of difficulties. So what's the alternative here? What's the right way to do this so we avoid these two problems? What we've been discussing up to now, we usually call offset-based pagination, and the alternative concept we sometimes called keyset-based pagination. What it basically means,
it has like 10 other names.
Right? Like I've heard also it's called seek-based pagination.
And cursor-based pagination.
Cursor-based.
So these are like the most well-known three. So
Yeah.
if you see one of them, we're talking about the same thing.
Cursors, I'm personally a bit apprehensive because cursors have already a meaning in relational databases. So there's a little bit of ambiguity when you talk to me about cursors. I'm thinking about actual SQL cursors, and that's not what this is about. That's another subject. But yes,
exactly.
Anyway, regardless of what you actually call it, the basic idea is super simple. Instead of using skip here, what we're basically going to do is we're going to use a where clause. Okay, it's extremely simple. And what I'm going to do, this is not a completely precise example, but what I'm going to do is I'm going to use a where clause to indicate what is the last row that I got in the last page. And I'm going to say, give me the rows starting from that thing. Now I'm going to take a second to make sure this is understood, right? Usually when you have a pagination application, the client remembers the position of the last page, right? And then when the user does next, the client goes to the server and asks for the next page based on what they remembered in the state. So in offset-based pagination, what the client remembers is an absolute position in ordering, right? I saw up to the 20th row. Now I want row 21. In keyset pagination, what you say is the last row that the user saw had the ID 20. What I want now is starting from ID 21, the next 10 rows. And because we have an order by clause, what that means is completely unambiguous and clear. And what we get is rows 21, 22, 23, 24. I hope that is clear to everybody. Now, the crucial thing here is that when you use the where clause, obviously you're using an index. So we're back to the performance kind of thing, right? So indexes are geared specifically to solve this problem of finding the row with the value over which the index is obviously defined, right? So this where clause that you see here is executed super quickly compared to that skip row that we've commented out. We don't have to go through rows 1 to 19 just to skip over them. We can jump directly in the index. What the database does is jump directly in the index to row 21. And from there, everything is ordered and there's an index. So it takes rows 21 to 30, right? Based on our take. I hope that that's clear to everybody. It's not. It's deceptively simple in a way. When I first saw this, I thought, wait, this can't be. I mean, this can't be. This is. It's stupid. It's too simple, right? But it is actually. That's that simple. Now there's some tricks.
I think when we talked about this with the team, I argued with you about this. Like, surely this can't possibly work, and you were like, no, it does. It does.
Yeah.
There are reasons.
Yes.
There are reasons why everyone is using offset and not using keyset. I guess like one of them
Yes.
we'll talk about is offset has great ORM support. Like all ORMs basically support offset-based pagination, but not as much support keyset-based pagination. And there are also reasons for that, and we'll probably get into them.
Sure. Yeah, I'm sure we'll talk a bit more about that in a second. But of course, this being me and me liking perf, of course, we're going to do just a tiny bit of benchmarking to show you guys exactly what this means. So once again, I'm going back to my, to my code here. Remember, I've seeded my database with 1 million rows here so that we have a little bit of, a bit of meat in our database so we can show some perf. So I have a benchmarks project right next to this. If you guys have seen me before, this is a very common kind of benchmark project. I'm using benchmark.net. Have I said this recently? I think I've been saying this every single stand-up like I've been doing. Always use the benchmark.net library to benchmark anything that you do. Do not roll your own benchmarks with stopwatches and various things. Benchmark.net is an awesome standard package for doing any sort of benchmarking, micro benchmarking, and also just normal benchmarking. The .NET runtime and in general, when ASP.NET, .NET, and EF Core, when we want to benchmark inside Microsoft, inside our organization, we use benchmark.net to do that reliably. Benchmark.net takes care of various details like warm-up, making sure that you're not skewing your results because of warm-up, deciding how many iterations. Every time I talk about benchmarks, I have to say something about benchmark.net. It's an awesome library, and you absolutely should use it if you're benchmarking. Now, looking specifically at our benchmark, I'm going to go down here below. So what I actually did with this benchmark is instead of using EF Core, I copied raw SQL, and I'm using ADO.NET directly using NPG SQL. I kind of wanted to cut out EF Core from this specific benchmark to exclude EF doing anything here, although it is not doing any. It's not going to skew our results, but I still want to show like a more low-level kind of benchmark, just for fun. So what you see here is the offset pagination just does a normal select like this. Okay, so it's the same kind of select you saw before. The limit is hard-coded as a constant, and the value is also hard-coded as a constant. But I'm going to run this benchmark twice, once with 20. So I'm going to skip to the third page. I'm going to skip over 20 rows. And once with 900,000. So I'm going to skip 900,000 rows. I want almost the last page in the database, right? To show you guys the difference in perf between these two techniques. Now, everything is embedded as constants here, but that's not really that important. The keyset pagination thing does the same thing, but instead of doing limit and offset, it does where with ID is greater than. So I hope this is all clear to everybody. I don't think there's anything else that's interested here. This params thing is a very nice benchmark.net feature that does that applies the parameters automatically for me. So I have two methods decorated with the benchmark attribute. They will each be run twice with each param value. So benchmark.net basically takes care of all that stuff. So what I'm going to do now is I'm going to go down to my terminal here, and I'm going to run these benchmarks. So this is going to run against my local database here. And I hope this is going to provide us with some pretty persuasive results. I'm pretty sure it will. Generally, don't run your benchmarks when you're running tons of other things, like like a conference, like a streaming kind of thing.
You did shut down Teams, right?
I did not shut down Teams.
Oh,
I should absolutely.
Really slow then.
So now, if I do it in the middle, it's going to skew all my results again.
Yeah,
right?
yeah. Don't do it now.
I did. I already did. It's all going to be completely skewed. Okay, I'm crossing my fingers.
That's how we make everything look fast on the demos. You just shut down Teams after one run before the next run.
Hey, don't tell them my tricks. Right. Yeah. So this is taking a little bit more iterations. Benchmark.net calculates the number of iterations to run based on the variance. That's another very cool feature. So if it gets the same result every single time, if things are very stable and tight, then it's going to quit after a few iterations. And if it sees results going back and forth a lot, it's going to take more iterations to reach more certainty in terms of the results. I think we're almost done. This is not going to take a very long time. Here, by the way, you see that each iteration takes 4 operations. That's a long one. If four iterations take 120 milliseconds, we're not doing very well here in this specific scenario.
Yes, we do.
We do. We absolutely do. So we're seeing a lot of variance here, by the way, 80, 81. I have to say, when I ran this before without the streaming, less variance. The benchmarks stopped a lot earlier.
So after we see this, we'll pause for a couple of questions, because there's been a few themes coming across that people want some questions answers to. So
absolutely. I don't have a huge amount more. There's a few more things we'll talk about, specifically composite. What happens when you have...
Should we start asking the questions while this is running, and then?
I think
nearly done?
I think it's nearly done. It's only 4 iterations, and I think we're in the 4th. Can Jeremy do his thing with the...
Oh yeah, everybody move their mouse pointers around, right?
We're done.
It's oh, okay, worked.
We're actually done. It did work. Okay, so there's something that stands out here. Let's see if we can locate what it is. Can anybody locate what the weird thing is? Okay, so first of all, you can see that with 20, with skipping over 20 rows, the results are pretty similar. I was actually surprised to see keyset pagination slightly slower. So mind you, we're talking about 20 micros slower. This is very, very negligible in the grand scheme of things. I was still a bit surprised, and I would theoretically love to dig into this to understand why, but yeah, we don't care that much about it. What's more important, obviously, is when we want to get to row 900,000, we pay just as much, even a bit less in the keyset pagination scenario, but we pay a whopping 124 milliseconds to do that for the other one, for the offset. So I hope that drives... Yeah, I mean, percentage-wise, this is pretty dramatic, obviously. I hope this drives the point home. Skip. Sorry, go ahead.
And it's good to note that in this specific example, there are 3 columns. When there's a table with a lot more columns, this will be much more pronounced, the results.
Yeah. Yes. Yeah, this is a very tight and constrained and reduced kind of simplified scenario. Things will vary and might get even worse in various other scenarios. Exactly. So really, you guys should take this to heart. Anybody doing pagination where the data set is maybe a little bit big, it's really worth thinking about this. Okay.
I would say there's an exception to this rule. So I have more of a moderate opinion when it comes to keyset versus offset. I'd say the exception to this rule is if by design your application only allows accessing, let's say, the first 10,000 pages. So your data might be just a lot more than that. And but if your application just allows the first fixed amount of pages, then I would say the advantages for keyset over offset is diminished in this specific case. So this is
I see what you mean, and I think if we had a graph here of here we have only 2 values. If we made a graph, we would see 2 lines gradually separating from each other, right? I think that's basically.
I think this kind of graph is included in the one of the links. I'm pretty sure.
Yeah,
So
there's several. Yeah.
To some degree, this is a performance thing, right? It's like, okay, if you like Mohammed, like you were saying at the beginning, if you measure the performance and you do it right, and you're saying, well, I've got 1 million rows, and and then I see that there's performance difference, then you want to say, okay, I need something different. If your performance with your data set and what you're showing is fine with skip and take, and that makes everything easier elsewhere, then just keep doing that. Simple, making things simple is king. However, I would say that it doesn't seem like the keyset pagination is that much more complicated. So, maybe it should be a default, first use.
So let's not forget, we discussed 2 reasons to not do offset. One was the perf, but the second one was also important. What happens with concurrency, right? And it's worth mentioning, when you use a where clause, then you don't suffer those anomalies that we just discussed. So if somebody inserts or deletes some row before, at the very beginning of the result set, that doesn't affect us in the least, right? What we're always asking for is for the rows following the last one that we saw in the last page. Okay.
So we had a question on that. How does this work if I'm removing records? Before you answer that, I just want to say to everybody in the chat, we're going to come to the question of if you have a non-numeric key sorting on a not an index, and if you've got complex sorting requirements. So I'm going to ask Shay about those in a minute, but let's stick on the removing records.
So maybe Mohammed, you want to take this?
Yeah, I've actually thought about this specific case before. So this depends on your requirements in the application. Like if it's acceptable to just show an error and take the user back to the first page, that might be a solution. If the specific record or the reference, as we say in keyset pagination, was deleted between viewing the first page and the second page, that might be acceptable. If it's not acceptable, you can implement some kind of logic in which you try the last record of the current page. And if it doesn't exist because it's deleted or something, you can try the one previous to that, and you can just keep going until you find a record that exists, which you can get the next page. So I'm talking here about specifically about if you want to access the next page of a certain page.
So just so I understand, Mohammed, so at least in this specific instance where BID is greater than some value, if the row with that value is deleted, then we still function well, right? Because we still get the next page of IDs.
This in this specific case, this works because you're kind of well, it also depends on your application. Maybe you want to check if the ID exists before you do the. So we're talking about an ASP.NET Core application, maybe where when you get an ID, you first try to get it, and if it doesn't exist, you return it for example. So this is quite dependent on the implementation of the application as well. Yes, but
sure.
So the specific solution I was talking about is when you do that and you return 404s for records that don't exist in the first place. So there are solutions for that. But if you're just getting the ID and inserting it in some way, this will this will still work. Definitely.
Right. Okay. Do we want to take more questions or move on?
I think let's. Let me see which one to choose here. So let's start with not multiple columns, but basically, so let's say we're ordering by a string, or you've got a GUID as your primary key, and you want to order by a string column, or start with that, or you basically don't have a natural kind of implicit ordering by primary key.
So I saw another comment saying, we never paginate by IDs, and that's true. I've shown this right now for an easy example, but right after this, I have an example with dates, which is more realistic. In general, the same idea works with dates because it's just another thing which you can compare. You can do greater than. It also works with strings because strings are also lexicographically sorted by collation in the database. Everything is fine. However, if you're not using, exactly, that's the comment I was thinking about. I completely agree. In general, you want to sort by date or something, and we'll show that in 1 second. One thing, though, is that it's extremely important to have an index, and that is, in fact, regardless of whether you're using offset-based pagination or keyset-based pagination. In both worlds, in both techniques, if you don't have an index, that's going to be really, really, really bad. Because the database, the database has to go through the entire table in order to do the order by, if it doesn't have an index. And so it's going to actually have to go through your entire table every single time you wish to query, which is a catastrophe.
So this has nothing to do actually with keyset versus offset. This is for the order by.
Exactly.
Yeah. So I wanted to. I think I would be correct in saying if you want to show multiple, if you want to do pagination, then you have to have a well-defined ordering. Otherwise, you're not going to be able to do it in a valid way anyway, right? I mean, there's a comment here which I think is incorrect. Like, skip and take don't need sequential identifiers. That is true, but you still need to be able to order the whole thing. So you don't really get away from this problem if you don't have if you use skip and take.
Yes, that's right. It looks like skip and take make it easier, but they don't really make it easier. You still have to worry about order by being completely deterministic. That's actually the focus of my next thing, which is my last thing before I hand over to Mohammed. But if you have a pagination that is not that does not have deterministic ordering, that means that as the user is doing next, ordering may actually change. Your result set might actually change, and you're looking at windows that are going like this, while rows are kind of like going like this every single time because the order is not defined.
Yeah. So Damien, hi Damien, had a couple of comments on this near the beginning of the stream, so pointing out problems that can happen if you don't have distinct ordering. Okay, so also this can be used if you're ordering by multiple different columns, right?
So that's what I wanted to get into now, because there's a little bit. So I suggest we move on, because there's a lot of the questions are relevant to this.
And then we'll come back to some more questions later.
Sure, so, I'll try to go fast because we still want to have a lot of time.
Plenty
for Mohammed.
Plenty of time.
All right. There is one thing that nobody's raised yet. I'm a little bit surprised. There is one problem with keyset pagination, and that thing is that it does not allow for random access. Okay, so if you have if your user interface is such that you have the pages down below, page 1, page 2, page 3, page 4, that concept is incompatible with keyset pagination, right? Because in general, when you have these pages, then each time you click on a page, then you just you use an offset, right, to jump to the right page. But with keyset pagination, all you have is the last is the ID or whatever the keys of the last row that you saw, and all you can do is ask for the next page or for the previous page. So keyset pagination is basically LinkedIn idea of pagination that goes forwards or backwards, but doesn't jump around. Okay, that's a very important concept. And once I kind of got this idea, I suddenly started looking at the internet in a different way. Every time I'm browsing my emails or my GitHub notifications, I now look below. Can I jump around? Like, do I have random access or not? And it's a very interesting question. A lot of interfaces actually don't really give you random access. They don't really allow you to jump to page 10. And all of a sudden, I'm not sure why they would. Why is it important for me? Like, what's the utility of jumping to page 10? Why? When would what's the user story of that specific requirement, right? Go ahead, Arthur.
Exactly. I want to just add something onto this, that a couple of examples where this makes sense as a use case for keyset pagination is, as you mentioned, first of all, GitHub commits, for example. There's no reason you would need to randomly access certain pages. This is one example. Another example that might not be as obvious, but it's probably the most useful use case for keyset, and that is like if there's a feed, and if there's an unlimited feed, so for example, Twitter or something like that, keyset pagination is perfect for unlimited scrolling interfaces.
So I was just going to... Oh, go ahead.
Go ahead, Jeremy. No, you go.
I was just going to say, this is the perfect place, though, that the key is determined by a business need, and you expose, instead of something artificial like a page, you expose that business need. So if I'm paging through names, I can absolutely jump to page that starts with B, C, D, E, F, right? So my paging should not be page 1, 2, 3, 4, 5, 6. It should be based on that business value.
So
that's a wonderful example. I'm sorry. Go ahead, Arthur.
No, so that links into what I was actually going to say, which is, you said there's a use case for this, and I ran into one of these recently, which is I've got a whole load of stuff, and I'm trying to find. I know it's something that it's a song, like I think it was on Spotify or something, and it's a song that begins with B, but so I want to find the songs that begin with B, but all I've got is backwards and forwards, and and if I could click kind of in the middle, I could guess. But as Jeremy says, the real problem there is not the fact that I can't click on there. It's the fact that the UI is not structured in a way that gives me the appropriate source, the appropriate way of finding what I'm actually looking for.
And just in case people haven't gotten the point of this, so if you want to have ABC down below, like Jeremy was saying, that's perfect. And that's actually a sort of random access that is in fact compatible with keyset pagination.
Exactly.
This is not, we're not using offsets here. We're not saying, show me the 100th song. We're telling you, show me all the songs starting from those which begin with a B. And
Yeah.
indexes actually do, you can use indexes. So in SQL, when you do like and you do starts with an A, as an index over the string typically will actually be used. So that would be a very efficient query, in fact. So it's not correct to say that random access is incompatible with keyset pagination, but the kind of random access which is just arbitrary pages, so the 5th page, that idea is kind of incompatible, yes. Okay. By the way, you can also do a hybrid approach where you do have those pages, and you can use offset-based pagination when you do random access. But then when you use the next and the previous button, then you're using so you can mix and match those two approaches. That's also a possible if you really want to support this. Now, I'm going to really show one last thing here that's important, and that's something a little bit more realistic. So remember, I have something called last updated, and as many people said, we usually don't want to sort by paginate by the ID. Instead, what we're going to do is go by the last updated here, and we're going to say, let's say that I want all the pages that are so we've already seen some blog posts, and now we're clicking next, and it so happens what we want is all those which are after this date. So if I do this query, let me reorganize things here a little bit. Then as you can see, okay, it just works, of course, and it looks great. And it seems like we've solved the problem. But obviously, there's a big problem here, okay? If we look at our blogs table, you will notice that there are several blogs with the same date. And this goes to the whole deterministic ordering thing, right? Our ordering in this specific query is not fully deterministic because there are multiple rows that match this thing. So what we have to do, this is a problem. Again, what this can do is if the page happens to, the current page of the user happens to stop in the middle of this date, then the next time the user does next, we will be skipping over some dates. So what you absolutely have to do here, you have to do something like this. I'm going to write it out. Either it's over that date or it's equal to that date. This is going to be a little bit long. And the ID is bigger than 4, for example. So what I'm trying to say here is that we call it keyset pagination because there are multiple keys.
Equal should be equal, not greater than.
Sorry. Exactly. Thank you very much. This one is equal, and that one is greater than. Exactly.
Live code review.
Thank you.
Fortunately, programming here.
Fortunately, Mohammed is alert here. So this is where it gets a little bit complicated. So when we have multiple keys that we sort on, we also have to order by these things, by the way. That's the other thing that I forgot to do. So when you have multiple keys, which you absolutely have to do in various cases in order to get a deterministic thing, then things become a little bit more complicated. In the client, you have to store both keys. So if the thing that identifies that last row is now 2 things, not just the ID, but the date and the ID. And when you're, when you want to select everything after that, then you have to do this complicated thing, which is either after the 6th or within the 6th, but after the ID that I saw last. So this is getting a little bit more complicated, but I hope people still get it. I will just say that in most databases, this can be shortened, simplified to this. And after this, I'm done because I feel like I've been talking for too long. But most databases actually allow you to do something like this. Okay, and this is a construct that, again, I don't think a lot of people are familiar with. This is called a row value comparison. Postgres specifically does this extremely well, and it's even more optimized than this row above. And I'm working on bringing EF Core support for this in the next major version of EF Core. But right now it's not supported. And unfortunately, this specific construct isn't supported by SQL Server, by the way, but it is supported by most other databases out there, relational ones. So my main message here is if you're using multiple keys, which you should be using to get deterministic ordering, then think about, you have to think about some extra things and consult the links that we have in the URL list, basically, because I don't want to spend more time on this. Is this anything else to say on this? Any questions?
We can move on, and then we'll do more questions at the end. There's certainly, I've got some more starred, so keep asking the questions. We'll either answer them in chat or we'll bring them up at the end.
Okay. All right, I think I'm done. I definitely want to see now, what Mohammed has to show us.
Okay, so for starters, I just want to say that this is probably why keyset pagination isn't used more, isn't well known. It's apart from the very simple case of having a single column, you're having a keyset pagination on. The syntax for writing one just gets longer and longer and longer, and it's more error prone, like Shay right now. So so hopefully we're gonna be showing some can you hear me?
Yeah, we can hear you.
Can hear you.
Okay, it cut out just for a second. Okay.
We're at the edge of our seats.
So hopefully this will make dealing with keyset pagination just a little bit more tolerable. So let me just, okay. So I wanted to introduce this package. So this is a package for EF Core. It's the keyset pagination package for EF Core I've been working on. The goal here is to allow you to work with EF Core to create your keyset paginations without having to write conditionals yourself. Conditionals are more error prone to write, and they get longer and longer the more columns are added to the keyset query. So the goal is to just use a method, just like any other link method you would be using. So this is called keyset paginate. It's an extension method on top of iQueryable. So you would use it just the way you would use any other link method. So what we want to specify for keyset pagination is, first of all, we want to specify our keyset columns. So this is here. So this is the first argument. In our most simplest example, this was it was a keyset pagination over the ID column. So this is how you would specify the keyset query. In more complex examples where you have multiple columns, you would just keep on adding columns to this query. So the second line is what we call the direction of the pagination query, and this will become clearer when we explain this below. And the third argument is the reference entity you're doing the keyset pagination against. So this might be just a bit complex to understand right now. It's because it's a single method that will allow you to create all the keyset queries you want to use, whether you want to get the first page, the last page, the next page, the previous page. So this is a single method that will allow you to do that. So first of all, yes, I forgot one thing, is that the keyset paginate, the keyset query, the keyset column you specify here will also set the order of the whole query. So we're saying here that the order of the query is ascending on the ID column. So okay. So let's keep things simple for now, and let's say we just want to get the first page for our keyset query. We just run keyset paginate with only the first argument, and we're telling it that it's ascending on ID. So this is pretty much the only required argument to the method. So as you add more and more columns, you just simply add them to this argument. So this is specifying that we want the keyset to be ordered first ascending on ID and then ascending on as a score. You can also, of course, mix ascending and descending columns. We can order by ascending first and then descending on score. Let me just jump to the comment patterns, and this will probably be much clearer. So there are 4 comment patterns for when you want to do keyset pagination. first page, last page, previous page, and next page. I explain here how to use each one of them. The first page is, as we said, you just call keyset paginate with your keyset columns. The last page is very similar, but in addition, you specify the backward direction. And the way to understand this is, if we look at this fast, so the way to imagine this is that the first argument, the keyset column, so we said that this actually specifies the order of the whole query, and the direction is what specifies how to work that data, if you can imagine it like that. So with a forward direction, we're just working the same way as the order. With the backward direction, we're working against the order. And so if we want to get the last page, what we want is to actually order the query in reverse. So we actually have to flip all the order clauses if you're writing the SQL by hand. But using keyset paginate, you can just specify the direction and it will automatically handle generating the correct order clauses for the query. So
does that mean then if you switched it around and did descending, you wouldn't need backward? You would basically be the same thing. It's like they're inverses. So if you had ascending and then backward would be the same as descending and not backward, and descending and not backward. Yeah. So yeah. Okay. So it's
what you would do,
ways of getting to the same thing.
Exactly. So what you would do is, if you have a page where you want to display, for example, records by their descending creation date, for example, so you will create this keyset pagination with the keyset columns being descending on created, and then if you want, and then to support all the functionality of the keyset pagination, first, last, next, previous, you would just use the direction and the reference, and it will take care of the rest. So this might be just a little bit confusing because so Shay only showed like it's a very simple example. It gets just a bit more complicated when you want to actually get the previous page. So the previous page is just a bit more complicated than the next page, the same.
So to keep it straight in your head, it seems like it's a good idea to just do the ordering in the way you think about it from your business perspective or whatever, the way you want to display things, and then use forward or backwards, and not even trying to figure out or think about the fact that you could reverse those. Just don't reverse them. Keep it simple. Keep it the way you think about it, and then your head won't get exploded or whatever.
If you want to understand exactly how keyset pagination is working, I would definitely recommend to check check the SQL is generating.
Exactly. Yes.
Yes, but if you don't care about the details, you can just use it as it is, and it should take care of the rest. This is why I created this package in the first place. And actually, I still consider this package to be a bit on the lower level side. You still need to understand, like, even if you don't understand exactly how keyset pagination works, you still need to understand that, for example, calling this with a backward direction will actually get you a previous page if you give it a reference. So I do have another package that actually builds on top of that. We can talk about later. That is much easier to consume. So for now, understanding how to use keyset pagination is, I think, is still important.
Yeah, and you still need to understand which properties, which columns you're going to do the sorting by, and make sure that that's going to give you the consistent sorting. Right? It's not going to magically fix any of those issues if you sort by the wrong thing, or it's not unique or whatever.
So for the other package I'm talking about, the only thing you would have to provide is actually just the keyset column. So that is the first column, and it will take care of the rest, basically. So we'll take a look at that later. But I still recommend trying to understand what keyset paginate is doing here. So we were talking about the previous page. And so, as we said, this is going back in the backward direction because we want to actually work backwards from our reference. So yeah, so actually the last page and the first page are just special cases of next and previous. They're just the same, but with the reference being null, basically. So after calling keyset paginate, the reason why I still consider this a bit on the lower level side is you have to do a couple more steps, basically, to ensure you're displaying the results correctly. So working backwards actually gives you the results in the reverse order to what you specified. So of course, if you show them as they are on your page, they will be completely wrong. They will be on the reverse order. So you still need to call this basically just tests if the direction is backward. It will just do a reverse on the list, basically, so that you get the data correctly ordered, no matter whether you're going forward or backward. So the keyset paginate actually doesn't return the results directly. It returns what's called a keyset context. The reason for that is we'll see a bit later, but one of the reasons is to call ensure correct order. But it also has the property that is query. This is basically the generated iQueryable, and you can treat this as just like any other query and call a link on it. So if I want to, like the size of my page is 20, I can just do a take. We're not doing a skip, so that's the important part. So yeah.
So the keyset context basically keeps track of all of the state around it, so you don't have to worry about that. You just say, give me the next one.
Yeah, that's really nice to have this sort of thing just above that kind of already encapsulates all the key sets, right, for the current row, the last row, and then you just drive it through that.
Exactly. So this is like a small example that should make this easier to reason about. So we're just doing a keyset pagination over users. We'll just call keyset paginate. We'll do the arguments. We'll specify the direction. We'll specify the reference. And when we get a keyset context, we can just get the actual data, the actual users, by accessing the query and then taking the size of our page, calling toList async. And then we should ensure the correct order for users. And then the other important part where keyset context helps us here is it actually has helper methods for has previous and has next. And this is exactly for when you're displaying the buttons on your page and you have next and you have previous and next and first and last, and you want to disable the buttons when you're at the last page, for example, or when there are no previous pages. So this is basically a Boolean that tells you if there are more data before this list and more data after this list. So you can use this in your UI, basically, to disable buttons.
Just a perf question for me. So I'm assuming that typically when I do next, I would be doing two round trips, two queries to the database, right? Once to get the next page and another one to see if there's more rows.
Exactly. So this basically does a couple more queries. This is it basically reuses the keyset, the generated keyset close for ordering, and then it just adds. I think I can't remember, but it just like checks if there are more data after or before, basically.
So just a thought, it might be possible when you do the first take 20 to in fact internally do take 21 and use that as to know whether there's another page, and you save like the extra query and round trip. Maybe it's an idea.
That's a great idea for next, but I don't think it works. I'm not sure if it will work for previous.
Okay,
but that will still save, I guess, an extra round trip. That's a good idea to consider.
Sure.
Yes, definitely.
I'm obsessed with round trips. Sorry, I see round
Well,
trips
that's-
everywhere.
That's
See,
essential.
see the last stand-up for
Yeah,
the
exactly.
number of round trips. As many round trips as you could ever want.
Okay, so there are a couple more examples of how you can use keyset paginate without losing any kind of functionality you need. Like, for example, if you want the total count, you can do that. So yeah, basically you lose nothing. You can use keyset pagination without using any kind of functionality other than the one given to you by offset-based pagination. So this is something Shay talked about, so I probably won't go over again. But there are a few gotchas to worry about, even in keyset pagination. So this is what Shay mentioned by you need your keyset to be deterministic. You need it to be always to resolve to exactly one data reference. So yeah. Indexing is also, Shay also thought about that. Like if you're doing a descending on created, if created isn't indexed, this will do a table scan. It won't be using an index, so you lose performance. So you have to think about that. If you have multiple columns, and I don't think we mentioned that. So if you're doing a descending on score, for example, then ascending on ID, you need to have an index, either like an index on score might help if there's a single index on score. I'm not sure, but if you want like the maximum kind of performance, you would probably need a multi-column index on score and
Right.
ID.
That's right. Yeah.
So
Usually your index has, like for best performance, your index really needs to match your order by clause.
Exactly.
Basically, this is what we're saying here.
Exactly. So this is basically keyset paginate. I want to mention a few things. So first of all, the way this is implemented is by simply generating the conditionals that Shay was writing, by generating the conditionals and the order query, the clause that Shay wrote in this sample. So later on, we talked about raw value. Later on, if EF core implements raw value, I'll be able to use that in EF core. But there's one thing to mention that Shay didn't about raw value. So raw value will work when you have order agreeing columns between in the keyset. So for example, if you have ascending then ascending, you can use raw value. But if you have something like this, for example, descending then ascending or ascending then descending, if you're mixing the order in your keyset, you can't use raw value because well, that's just how it is. Raw value takes a single operator. So yeah, this is something to keep in mind. So in this particular case, if you're using keyset paginate as an optimization, when raw value becomes available, if we can use raw value, I'll implement it in a way that it will generate a raw value. But if it can't, it can still generate probably just a little bit less efficient query, but it'll still work with all of your cases.
Okay, so should we get to some questions? So there's a couple on your stuff specifically, Mohammed, which is one is let's see, is it compatible with all EF core providers? Which I assume the answer is yes, because it just builds on top of what EF is doing, right?
Yes, it's compatible with all
right.
providers. Yes.
So all it's doing is manipulating the link query, right? So
it just generates link conditionals. Anyway.
So then it will be translated to whatever way the provider is doing it. So answer to that one. And then somebody wants to know how you're getting the file icons in GitHub. What's your extension there? If that makes sense.
Sorry, I'm getting like double audio for the stream. I'm not sure why.
Sorry.
Okay, I found out why. Okay, that should be fixed.
Okay.
Okay.
So what are
so
you
can
what are you using extensions? What extension are you using to get those cool file icons in GitHub?
I actually don't even remember. I can just comment it. Like I'll find out.
Okay.
I have a lot of
Good.
extensions, so I'll find
Sounds
out
good.
and comment it on the
Okay.
YouTube video after I'm done.
Okay, let's we're over time, but we're going to answer questions anyway. We always go over time; it's tradition on this stream. This was asked earlier, and I don't really know much about it, but I know I've seen it mentioned before. So this deferred join, which I think somebody had said on Twitter, was something that MySQL can do. Does anybody know about this? If not, then yeah, I guess that's something we need to learn about.
Deferred join. I'm curious.
Okay. Well, we can't help you with that
That's
one
our
right
answer
now.
right there. Curious.
Yes.
I've been nerd spanked here.
So this isn't directly related, but this is a question we get quite a lot, which is, how can I get total rows and results without having to do 2 queries? And I don't think we have a good answer to this, but I was bringing it up in case Shay or Jeremy knows otherwise.
So we saw, we had this issue where somebody was doing a trick with EF projecting 2 queries into a single one. I don't know if you guys remember this, which doesn't always work very well. So we don't have a first-class way of basically executing 2 link queries in a single round trip.
I'll have to think about it in EF Core, but from a database perspective, you can do the 2 queries with a union join. So the first one gets the count and dummy placeholders for the rows, and then unions with the one that actually gets the page.
And we do actually. That reminds me, though, the thing that Shay mentioned. We do have an issue on the backlog that we'd love to get to, which is called query batching, which would basically be you give us a bunch of queries that you want to execute, and we don't do it immediately. We defer execution of those and then execute them all in one round trip and give you the results back. And it wouldn't be 1 query. But if from a perf perspective, it'd be effectively the same because you'll be doing 1 round trip to the database. So hopefully that we'll get a chance to, it's only 5 engineers on the team, but we'll get to it when we can. We do the best we can. Okay, so somebody just put another use case for this. Random access is Blazor continuous scrolling. Yeah, so anyway you're doing continuous scrolling, this is a very good solution.
Exactly.
And that's a good case where you actually can very, very easily end up getting to large, because I think somebody commented, well, you only ever look at the first page and a lot of results, right? But if you're scrolling through stuff, you can very quickly get to a point where your skip part is doing a large number and it's getting slower and slower.
Think if your paging is not something you click like next page, but rather linked to your scroll bar, and as you're scrolling, you're sending more queries to the database. That's a pretty good. Good scenario where this would be useful.
Let's see. This was a kind of interesting one. So if you've got 4 fields you want to order, do you need to have all the possible combination of indexes, especially if some of those can be omitted?
Do you want to say something to that, Mohammed?
Well, it's always like there's a compromise here between how many indexes you want to create. If you want the absolute performance you want to get, you have to create an index for each one of them. But if you want a compromise, if there is if there are 4 cases, for example, and all the 4 cases start with either F1 or F2, for example, you can maybe just create an index for 2 indexes, one for F1 plus something and one for F2 plus something. That might be more of a compromise, but yeah, there's no.
Okay.
Yeah, one comment from me. So yeah, as Mohammed said, you don't have to always have all 4 columns. Having less is also helpful, not as helpful, but helpful. And also keep in mind, so having a lot of indexes becomes a problem the more you do writes. Basically, if your data set never changes, if it's immutable, then there's no real cost of having an index, an additional index. The more you add writes, the more your application is write intensive, the more an extra index costs, because each write now has to go and update all of those indexes, right? So you have to also take that into account when thinking about, avoiding index explosion or not. That's another argument here.
Okay. So a few general questions, not necessarily about this show, but just so we're getting towards the end here. One is Neo4j provider. So we always get these questions. Are you going to do provider X, Y, or Z? I should say Z, not Z, because I'm back in the UK now. And the answer is usually no, but we definitely support community providers. The MySQL, Pomelo MySQL provider is community, Postgres provider is community. I mean, Shay does it and he works for Microsoft, but it's still a community thing that he started before. And there's a lot, so, we definitely support third-party community providers. Firebird's another one that has community. So while we won't necessarily do a provider, you can take it on. It's not easy, but it's worthwhile, I think. And then let's see, a couple of comments about Shay. He's a cooler, smarter version of a university professor. Yes, indeed. And
My God.
knows Latin and Greek and all kinds of interesting stuff as well. So he's a very cool person to talk to. However, he did claim that he has real bookshelves, but I will point out, as I do to anybody who asks this question, they're all rented. They're not his books. He's rented all those books. So it's a little bit
Living proof.
Yes, but they're all rented. They're not your books. I know you have your own books at home, but those ones specifically. Anyway, shout out to Eric EJ. Yes, we always like to give a good shout out to Eric EJ, Power Tools, and general contributor. Thank you to Eric as always. And then somebody saying they love me and my cats, and they miss the cat. So here is Alice there. She's sitting on her thing on the window ledge there. So she's chilling in the sun and refusing to come over with me. But we have now shown you the cats. So for all those people who just come here for the cats, there it is. And I think that's probably a good place to end. So
I'd like to just add that I really like what Mohammed has done, and I also love that there's EF Core here is a sort of a low level thing,
yes,
and then which is good to understand. But then you have this thing that builds on top of it and simplifies it and takes care of a lot of the complicated stuff for you. So it's one of the more it's quite an impressive package, like among all the extensions that I've seen. I really like what you've done.
Agreed. And we had a goal of making EF Core extensible, and we really appreciate when people put packages out there that really add functionality to that. So thanks, Mohammed, for that, and everybody else who does.
Thank you. I just want to add one thing. So we didn't mention it. There's an issue that it's in the links. That's allow users to express SQL or value comparison syntax. So it contains a bit more about the performance implications between raw value and written by hand conditionals. And so if you're interested in that kind of thing, you can check it out. It's it has a lot of info. So yeah.
Okay, so with that, I think we will say thanks at this time, and we'll see you again, hopefully in another 2 weeks if we have a topic to cover. But we always
practical testing.
Find something. Is that what it is? John P. Smith, practical testing?
John P. Smith,
awesome.
practical
Good
testing.
Stuff.
Yeah.
Okay. Bye, everyone.